Good afternoon. My name is Darrell. I am the Executive Vice President of Strategy at FutureOn, a Norwegian software company working in the offshore oil and gas space for digital twin transformation. 2002 has been one of the most unpredictable years in living memory for the human race. However, amongst all the fear and uncertainty caused by the COVID-19 virus and the upheaval of entire industries, including oil and gas, one event stands out as perhaps the greatest in human endeavor and historical achievement. On May the 20th, 2020, in the midst of the global pandemic, SpaceX launched a rocket with a space capsule that contained two men and some of the most incredible advances in technical, digital, and robotic technology ever witnessed. Those two crew members, Doug Hurley and Bob Behnken, boarded that space capsule, which they had named Endeavour, for the 27-hour trip to the International Space Station, knowing that they had front row seats to what might be considered one of the best demonstrations of a digital twin ever built. From takeoff, including the self-landing of the reusable Falcon rocket on a tiny floating platform in the ocean, into orbit, flight, and docking into the International Space Station, and then final re-entry and pinpoint landing in the Atlantic Ocean a few weeks later. Every single aspect of the trip was fully automated, remotely monitored, and entirely digital. Bob and Doug really had very little to do except watch the show like the rest of us. An exact digital replica of the Dragon capsule allowed remote Earth-based operators to monitor the status of Dragon in real time based on data received from hundreds of sensors integrated within the spacecraft. But the digital twin of Dragon was not an afterthought. From the very early prototype designs in 2004, the entire project was developed to be fully digital from its very beginnings. This challenge required hundreds of engineers and scientists with a broad array of knowledge and skills to collaborate across their disciplines to build a rocket that was greater and smarter than any one of them could have imagined single-handedly. That same vision of digital collaboration must become a fundamental truth to equal or exceed such awesome success in every complex business, including oil and gas. So how do we get there? First and foremost, we must start with the data. The fundamental challenge for all complex projects, whether it's an energy or a space project, is understanding how to harness the data that we either already have within the organization or we will collect over time as the project develops. Often that data isn't in some structured or easily accessible format. It may be on someone's hard drive, perhaps in a spreadsheet, or in a PDF file that's locked, or in a proprietary format, or embedded in a vendor-specific document. More often than not, the information is simply knowledge stored in an individual's brain that has not been documented in a way that is accessible to others. For those of us who support the energy companies that have a vision of fully autonomous digital twins of their offshore oil and gas operations, the development of that digital twin and the capturing of all the key data must start at the very beginning of the project. But instead of capturing and analyzing data around gravitational forces, flight trajectories, and docking processes, like SpaceX did, we have our own unique set of data challenges that must be brought together to form the basis of the digital model. These data sets include seismic modeling, reservoir analysis, potential well path trajectories, location and GIS data, subsea surveys, existing infrastructure, environmental conditions, and equipment specifications, to name just a few. The challenge is to bring these effectively disparate data sets together first, and then provide the environment and the tools to allow different engineering disciplines to work together with a common goal in mind. And this collaboration must be done at the earliest phase of the project, so that digital ideas and efficiencies, sharing of workflows, then become a fundamental part of the project DNA. The good news is that this industry is waking up to the need for open collaboration at a data level, as evidenced by a number of industry initiatives and directives. A great example of this is the Open Group, who have established the OSDU data platform. This data platform provides an industry-agreed approach to centralizing the important data sets that are needed for industry collaboration to actually happen, to function. Other initiatives include Concraft amongst the Norwegian oil industry, as well as digital twin standards that are put together by compliancy experts from companies like DNVGL, but supported by competitive supply chain vendors. These initiatives and directives are now being supported by important industry bodies such as the IOGP, who recently established a subcommittee known as DISC, that is defining ISO standards around digital data compliancy specifically for the oil and gas industry. So when these data types, formats, standards, and everything else all start to come together, what does that really mean for the operator? Well, an important part of the digital twin is actually being able to visually represent how the various data sets align in context. Using geospatial modeling software, such as FutureOn's Field Twin platform, you can now bring all these data sets together in a single geospatially correct 3D model that captures the entire upstream digital twin in one contiguous digital representation. So seamlessly bringing together seismic data from the subsurface, well path trajectory plans, pipeline and riser designs, and host infrastructure, all in one single contiguous data model. This can now be used as a baseline for complex simulation, cost analysis, flow analysis, and all sorts of simulations before anything is built. Having an accurate and usable digital twin of your concept design in the earliest phases of the project can shave thousands of hours and millions of dollars off the eventual cost of building and operating the physical asset itself. So stepping back, you can start to see how the use of data at the very early phase of a project is important, at the time when ideas are being appraised and reservoirs are being analyzed. It's clear that these data sets and how they're available will impact later phases of the project. So even in this early phase, the basic framework for the digital twin is starting to form. We call it a discovery twin. As each new phase of the project is entered, the twin evolves from discovery to concept, to engineering, to as-built and as-laid. In each phase, new data is captured, and the increasingly complex and sophisticated digital model develops. But no data is lost, no knowledge or no decision is lost to the internet. The same model is the basis of the model that will ultimately form the operational twin. And to be honest, project handovers of PDF files and blueprints and DVDs really should be a relic of the past. And having a true digital project will certainly send them there. Today, all your project data, all your decisions, all your knowledge can be stored, maintained, and developed in a central, holistic, intelligent digital model that develops over time as the project evolves. And even after operations has begun, that modeling process does not stop. Even though incoming real-time data from sensors and IoT devices will be actually used to monitor the asset, perhaps compare the real-time knowledge to the simulated data, that data can be used for algorithms to scale that performance of the asset from being something relatively simple and diagnostic into something fully autonomous, much like the Dragon space capsule. But that same data that is being used to create that autonomy can also be reapplied back to the design process. And that data that will then provide insights into how how certain equipment may be operating, the efficiencies of certain flows to enhance and improve future project workflows. The idea of having a complete life cycle digital twin from cradle to grave that starts in early discovery but evolves to this truly intelligent and autonomous digital twin is fundamental to the success in digital twin development. And this approach is rapidly becoming the standard for all new oil and gas projects in this sort of new normal world that we live in. New normal being far fewer human resources available and low price, very low priced cost of fossil fuel driving tight margins and requiring significant efficiencies in all aspects of a project. FutureOn's Field Twin platform is being used today for exactly this role, for designing and developing digital energy fields across the industry. Global operators, equipment vendors, EPC companies, and software developers are all now collaborating using our Field Twin platform to conceptualize complex offshore oil and gas projects from early phase to production. Our customers and partners are seeing the benefits of new ways of thinking digitally, driving internal and external knowledge sharing for faster project times, better and more efficient designs, resulting in earlier and lower cost recovery. It's a lot to consider, but as your digitally focused projects evolve, bear in mind that even though you might feel like you are breaking new frontiers, incredible progress in digital transformation is already being seen across so many industries. In fact, Gartner ranks the oil and gas industry as 27th on the scale of digital transformation progress. So we have a long way to go. But it took Elon Musk and his SpaceX team 18 years of appraising, simulating, designing, testing, and engineering to carry 2 men into space in that Dragon capsule in 2020. But by making that project digital from day one, SpaceX is now reaching to infinity and beyond. Thank you for listening.